Hello friends and viewers, welcome to mathematics lesson. We are going to deal on modular arithmetic for today. Moving ahead, we can first express what modular arithmetic is all about for easy understanding. And we have it as in mathematics, modular arithmetic is a method of calculation for integers where numbers loop when getting to a definite value called the modules. So to understand what this thing is all about, we can express it by using 12-hour clock. We observe in 12-hour clock that clock moves and winds all over again at 12 hour, starting from the 0 hour to 12. After that, it starts all over again. Let's say we consider the hour, 24 hours can be read in a clock twice. So it shows that clock is operated in module 12. Module 12 is the operation of a 12-hour clock. So what that means is that when, for instance, we are at an hour of 5 o'clock, and somebody can try to determine what the time will be after 9 hours. We see that when we are using 12-hour clock to read that, we observe that after 9 hours from 5 o'clock, we are going to have 2 o'clock at a 12-hour clock. So that shows that after we have gotten to a point of 12 o'clock, the clock reads all over again, starts from 12 o'clock to what? To 0, 1, 2 to 12 again before it recycles again. So we can now see that when we are then at an hour of 5 o'clock and we add 9 hours to it, we see that the clock will revolve around the clock and come back to 2 o'clock to end after 9 o'clock. So this concept explains what we mean by modular arithmetic. So you can see it as a ring mathematics or ring arithmetic, or you can see it as a round circular stuff, something that has to do with in a circular pattern of calculation. So we are going to get more views about this as we solve these different problems on modular arithmetic. The first question says, find the values of the following in the stated moduli. So we have A, 8 operation 6 in module 5, and B, 63 operation arithmetic operation 78 module 6. So to solve this problem, we say A, that 8 operation arithmetic operation 6 module 5 simply means we have 8 plus 6, which gives us 14. So we are talking about 14 mod 5. What will be 14 in module 5? That's what the question is talking about. And to solve this, what we simply do is say 14 divided by 5. 14 divided by 5 is going to give us 2, remainder 4. So the remainder in this idea, in this situation, is the answer we are looking for. So we are having 4 as the answer, or 4 or 14 mod 5 is equal to 4. So here we can say that 14 mod 5 is same as equal to 4 mod 5. So that is how to solve that. So the second one says 63 arithmetic operation 78 mod 6. So this will be equal to 63 plus 78, which will give us 141. So we have 141 mod 6. So to find this, we are looking for 141 to a number to represent 141 in module 6. So we can look at 6 multiplied by 23 plus 3. 6 multiplied by 23 plus 3 will give us 141. So the remainder here is 3. So we have it as that 141 mod 6 is equal to 3, or we can simply say that 141 mod 6 is equal to 3 mod 6. So 141 mod 6 is same as 3 mod 6. So that is 3 is the correct answer to that. So that is how to simplify problem on modular arithmetic. So moving ahead, we have a question which says copy and complete the following table for multiplication module 11. Use the table to evaluate 9 module 5, 9 multiplicative arithmetic plus in brackets multiplied by 10 module multiplicative arithmetic multiplied by 10. So this is what we are asked to use it to solve, and also we are asked to find the true set of this and that. So to solve this problem one after the other, we first of all complete the table. To complete the table, we are dealing on modular arithmetic of 11. The mathematical module we are talking about is mod 11 arithmetic. That's what we are dealing with. So it means that after 11, the count of 11, the number rewinds again. So you should know that 11 in mod 11 is actually equal to 0. So after the count of 11, at the count of 11, the counting reverses to 0. So that is what it is. So we use this to complete this table. To complete this table is actually multiplication of numbers, but we make sure that the numbers we are going to have in the box must not be up to 11, but it must be less than 11 at all times. So that is what we do to complete the table. So for instance, we have the part of the table has been completed. So to finish up, complete the ones that are not done. Say 5 times 5. 5 times 5 will give us 25. So we now divided by what? Divide 25 by 11. 25 divided by 11 will give us 2. Remainder 3. So the remainder is 3. We are going to write 3 here. Again, 5 times 9. 5 times 9 is 45. 45 divided by 11 will give us 4, remainder 1. So the answer here is 1. Again, 5 times 10 is 50. 50 divided by 11 is equal to 4, remainder 6. So what we are going to have here is 6. Again, we have 9 times 5, which is 45. 45 divided by 11 is 4, remainder 1, as we have said before. And then 9 times 9 is 81. 81 divided by 11 is 7, remainder 4. So we have 4 here. Next, 9 times 10, which is 90. 90 divided by 11 is equal to 8, remainder 2. So we have 2 here. Next, we have 10 times 5, which will give us 45, which will give us 50, sorry. 50 divided by 11 will give us 4, remainder 6. So 6 is what we have here. 10 times 9 is equal to 90. 90 divided by 11, which will give us 8, remainder 2. So we have 2 here. And then 10 times 10, which will give us 100. 100 divided by 11 will give us 9, remainder 1. So we have 1 here. So that is the way we can complete the table. So to solve what the question that follows, you say evaluate 9 times operational arithmetic addition of 5 times. Okay, we are to use the table to evaluate this. To evaluate this using the table, we go to the table and see 9 times 5. 9 modular addition or modular multiplication. 5 gives us 1. So we have this to be 1. Modular multiplication. 10 multiplied by 10 will give us 1, which is 1. We have it here. So again, 1 from the table, 1 modular multiplication multiplied by 1 will give us 1, which is 1. So the answer to this is 1. So 1 is the answer to that. Again, moving ahead, we are to find 10 modular multiplication n is equal to 2. From the table, we look for what when 10 multiplies to a number, it gives us 2. When 10 multiplies to a number, it gives us 2 from the table. When 10 multiplied to a number gives us 2 is here. This is where, and the number that gives us 2 when multiplied by 10 is 9. So 9 is the answer to that question. So therefore m is equal to 9. Again, n modular multiplication n gives us 4. What we do, we go to the table, we look for where 2 numbers multiply themselves to give us 4. The set of 2 numbers multiplying themselves to give us 4 can be found here. So is there any other place 2 numbers multiply themselves to give us 4? No. So the set of that will give us, the true set of that will be equal to that. N is equal to 9. N equal to 9 also is the correct answer to the question. Thank you for viewing.